Okay, so I can hope that dates that see that how simulate the surface that you are electronics lab in Proteus. So process is same that you have done in the new project. Then you can write any name of your choice. I recommend that to name it on the tab that you have performed. For example, having before that was how next. You don't need the schematic, but you don't need the PCB. So you are not making the PCB. So from where to where basically the know how to make system and they are on the channel too. In this video, we particularly talk about how you can use the function generator CRO in this topic. So let's make a simple circuit first. We need a resistor, then a diode. Let's say we are using 1 and 4 in lab. So one diode and for example, we can buy clipper circuit. We know that buy clipper circuit. See source or there. So let's see. We have, we have a battery. We have a voltage circuit. So there is a battery and then a diode that's separated to make parallel clipper. Parallel clipper, you are taking out cross diode at this question. So this is the simple circuit. Then input. For the input you need to generate. We will find generator here. So yes. Yeah. We will select here and then select signal generator. We will place it here and from the positive side of it you will connect it with the circuit. From the negative you will connect it with the other end. Now you need a ground. Ground will be available in terminal code. So we connect it ground. Now you need the CRO. CRO will be the same code structure where there was signal generator. Now this the name of oscilloscope. Now you have oscilloscope where you check it out then where which will be generating a pattern input this way. Okay. We were inputting a different signal as everything like input square signal or sine signal based on what is there in the lab. Now you have connected channel with your diode. It automatically that will check the output between this node and your ground. First, that it automatically takes ground as a reference. Okay. So it will measure and check the output between this and this node. And unlike the CROs in our lab, this CRO has four channels. One, two, okay. You have connected your output to channel. Now, now it's very simple. You need to run the simulation by clicking here. Now you will probably see two tabs. One for physical computer and other for the digital oscilloscope. If in case you don't see these tabs, You can select, you can check this from tab debug. In debug, you need to check digital oscilloscope and VSM signal generator, okay, whether these are enabled or not. Okay, probably if these two are not visible, these will not be enabled this in this place. You need to select 3 and 4 to enable them. Let's give a scale wave. For giving scale wave, you need to click this until scale wave is selected. Okay, the selected and then you need let's say frequency. This is tab, tab, and these two are frequency. For example, set it to 10 and here to around 1. It means this is kind of a multiplier. So 10 into 1, it is 10. And if you set this to 10, it means 10 into 10, 100. If you set it to, let's say, 1 from kilohertz, this portion of the scale is for kilohertz. It means 10 and then into 1 kilohertz. So totally it will be 10 kilohertz. So you need to select the frequency. Let's say I am selecting 1 kilohertz frequency and then amplitude. Again, selection scheme is same. You need to first select the level and then, for example, if I set the level to 2 and range to 1, it means it will be of 2 volts. Okay. Now, if I set it to, let's say, 7 and here 1, it means it is 7. But if I set it to 0.1 range here, it means it will multiply this 7 with 0.1. So it will be around 0.7 watts or 700 milliwatt. Now our wave is set to, let's say, 7 volts. Now we need to check if our CRO is working or not. As we have connected the output to channel number 1. Now, settings are same as as in the CROs in lab. For that purpose, as I told you in the lab, you need DC coupling. Okay, so you have to set the coupling to DC, and then as the frequency is about 1 kilohertz, so you need to set the horizontal calibration with respect to that. Uh, oh, I think so. I have not set the voltage. Yes, this voltage is too high. Let me do some changes in the circuit. This voltage is too high because input is 7 and this is around 12. So this will be a trouble. 1.5 here. And now again run the simulation. And as you are seeing, now tabs are not visible. So you need to enable it from debug section. This is the digital oscilloscope and this is function generator. And I think so settings are the same. You just need to select scale wave here and again DC coupling from here, and yes, you need to set the horizontal scale and then the vertical scale, and you will see that your output wave will be visible. You need to check its properties. You simply need to select cursor and then touch anywhere and it will show you the properties. So its peak value is around 3.6 upper peak and lower peak is around 8, 0.8. So that is how you can perform the same experiment on Proteus as well. So try to complete the lab manuals physically in the labs, but in case if some portion is left, you can perform it on Proteus as well. Thank you so much.